Hello, this is my video for design assignment 1 for CPE 301. Right here, as you see, this is my main assembly code for dividing a 16-bit integer by an 8-bit integer. As you can see here, I have my 16-bit integer with num L and num high, integers 16 and 17. My divisor in R18, my remainder in R21, and my quotients, the high and low bits in R19 and R20. I start at memory address 0. I load in a hexadecimal value of 3C and E7 for the high bit and the low bit, and then load divisor with hexadecimal value of 16 or 22 in decimal. And then I start off with a loop of incrementing the quotient, seeing if it's comparing it to register R0, which is 0 in this case. Then the loop branches if it's not equal, which it's not, to loop 2. We subtract the lower bit from the divisor, or we subtract the divisor from the lower bit, subtract the numerator with R22, but it's subtract carry, so this is just 0. So whenever this becomes a negative value, or just goes back from 0, this becomes -1 and it subtracts. Then if this carry clears, which means when this goes to 0, it'll not branch off, but it'll skip the branch and come down. Otherwise, it'll just go back to the loop and it'll repeat the cycle. Once it does, though, it'll decrement the quotient. We'll add the lower bit and divisor so we can get the numerator. And also here, in order to get the recursive subtraction to work, this quotient will go past 255, and once it does, when it hits 0, it'll go ahead and increment the quotient, letting you know that you've gone past a full 8-bit rotation. So let's go ahead and see this program in action. Start debugging. As you can see here, we'll go ahead and just show a few steps. So loads the values, the registers, increments the quotient, compares, it's not equal, goes to loop 2, subtract, and then repeats until the conditions are met. And now if we go ahead, actually let's do a few cycles. So we'll go ahead and go to a point where the lower bit is about to be negative. So let's see, what is it here? 99, let's do a few more. What's it at now? 33, just one more. Okay. So this is going to be negative, but of course it only has a value from 0 to 255, so it's just going to go back around, so it'll be like 245, as you can see here. So now there's a carry, and now num h, which is 60, will go down. And this loop is going to continue to repeat until this is 0. Once it does, and also this also only has a value from 0 to 255, so once that passes that, because it will increment the quotient, which is the same as if you're subtracting a 16-bit from an 18-bit, you pulling a carry over, or not you putting but in division you putting a 1 in the place of where the higher quotient is, or where the divisor is. So let's go ahead and we have a break here, so we'll just go ahead and run the program until it's done. And it's done now. As you can see here, quotient 196, num 15, 0, the remainder is 15, which is f, which you can see here in R21. 2C4 is the total divisor, or quotient, sorry. And yeah, that is about it for the assembly program. But now let's quickly take a look at the equivalent program. This C program that I wrote that does really the same thing, but just at a much uses a lot more simulation time. If we just go back here, actually you probably saw earlier it was around like 5,000, 6,000 cycles. But for this program, do I have break? Yes. Let's go ahead and start. Let's go ahead and start up. Now debug. So again, very similar. Char. So the actual logic works. Otherwise, similar. But yeah, higher, lower, remainder, divisor, and numerator. So while num_h is not -1, because it takes until about -1 for the program to actually work. We increment the quotient starting off, and then while again num_h is 60, so these loops are going to run for 60 each, 60 times. If num_l is greater than divisor, we're going to subtract it, and of course increment the quotient. Else, if it's lower than the divisor, or less than, sorry, we'll decrement the num, because that means we need to take a carry from it, because it can't subtract. Keep subtracting the divisor, otherwise it'll get stuck in an infinite loop, and then increment the quotient, because that still counts as you dividing it, basically. And this just repeats until this goes to 0. Or sorry, not 0, but -1. And once it does, if num_h equals -1, the remainder equals num_l plus the divisor, as we had in the previous code. And then we decrement the quotient and increment the high bit of the quotient. So just go ahead and just give a little test here. You can see it'll just repeat until 121. Until it's less, and then it'll go to the SO statement. Subtract again, go increment the quotient, and again this will just repeat. These loops will repeat for 60 times. So let's go ahead and just fast forward to the end of the break. Look at our last results. Remainder 15. As you can see here, quotient 186, and quotient high of 2. Of course, as you can see here, it took a lot more cycles, but they got the job done. So, and you can't really see from the registers here. Only in register 24 that you can see the 2, the hexadecimal decimal value of 2 for the higher, but you can't just hover over and just see the values. Anyway, that's it for my video for Design Assignment 1, and thank you for watching.